Hello everybody, Algebra here. We are finishing up section 1.2 today. We are working through problems from the Holt, McDougal, Florida Larson Algebra 1 textbook. And the first question for today is to tell whether the statement is always, sometimes, or never true. So for a given whole number x, the expression 6x represents an odd whole number. So if x is 1, 6x is 6. If x is 2, 6x is 12, right? 6 times 2 is 12. If x is 3, 6x is 6 times 3, or 18. If x is 4, 6 times 4 is 24, and so forth. And we can see that 6, 12, 18, 24, they're all even numbers. So the expression 6x represents an odd whole number is never true. So never is the answer for this one. Number 2, for a given whole number t, the expression 4t plus 1 represents an odd whole number. So if t is 1, 4 times 1 is 4 plus 1 is 5. If t is 2, 4 times 2 is 8 plus 1 is 9. If t is 3, 4 times 3 is 12 plus 1 is 13. And so forth. You can see they're all odd numbers, 5, 9, 13. So it represents an odd whole number. This is always true. This is always true. For number 3, for a given whole number r, the expression 2r plus 8 represents an even whole number. Just as for a review, odd and even. Odd is 1, 3, 5, 7, 9, and so forth. Even numbers are 2, 4, 6, 8, 10, and so forth, right? So for given whole number r, the expression 2r plus 8, so let's try a couple. R is 1. 2 times 1 is 2 plus 8 is 10. If r is 2, 2 times 2 is 4 plus 8 is 12. If r is 3, 2 times 3 is 6 plus 8 is 14. So we can see it's always even numbers. So this is always true. Next, for a given whole number x, the expression 3x plus 2 represents an odd whole number. So let's try a few. If x is 1, we get 3 times 1 is 3 plus 2 is 5. If x is 2, 3 times 2 is 6 plus 2 is 8. If x is 3, we get 3 times 3 is 9 plus 2 is 11. So we can see that sometimes it is odd, like here or here, but sometimes it's even. 8 is even number. So this is sometimes. So 4, the answer is sometimes. Okay. Then number 5, for a given whole number n, the expression n squared plus 2 represents an odd whole number. So let's try n equals 1. N squared is 1 times 1 is 1, plus 2 is 3. If n is 2, 2 times 2, 2 squared is 2 times 2, which is 4, plus 2 is 6, right? If n is 3, 3 squared is 9, 3 times 3 is 9, plus 2 is 11, okay, and so forth. So sometimes we get a odd numbers, but sometimes we get even numbers. So it represents an odd number. This is sometimes. Sometimes. That's 5. Number 6, for a given whole number s, the expression s squared minus 3 represents an even whole number. Let's try a couple. S equals 1. You get 1 squared is 1, minus 3 is minus 2. Then if s is 2, we get 2 squared is 4 minus 3 is 1. If s is 3, we get 3 squared is 9 minus 3 is 6, right? And then if s is 4, 4 squared is 4 times 4, which is 16, minus 3 is 13. So you can see that represents an even whole number, yes, but sometimes. Sorry, right here, not this one. Represents an even whole number, yes, like right here, this is an even, 6 is an even number, but it's not always, sometimes, because here we have an odd number, 1 or 13. So this is sometimes. So 6 is sometimes. Okay, and next, number 7, for a given whole number x, the expression x over 2 represents an even whole number. So if x is, let's say, 2, 2 over 2 is 1. If x is 3, we get 3 halves. If x is 4, we get 2, 4 over 2, or 2. So even, yes, but sometimes, right? Here we have an odd number. So this is sometimes. So 7 is sometimes. Okay. For 8, the expression 2t over 1 represents an even whole number. So let's try a couple. So t is 1. 2 times 1 is 2 over 1 is 2. If t is 2, 2 times 2 is 4 over 1 is 4. If t is 3, 2 times 3 is 6 over 1 is 6. So it's always an even number. So this is always, that is 8. 9, for a given whole number x, the expression 4x over 2 represents an odd whole number. So let's try a couple. X equals 1. We get 4 times 1 is 4 over 2 is 2. For x equals 2, we get 4 times 2 is 8 over 2 is 4. Let's try one more. If x is 3, 4 times 3 is 12 over 2 is 6. So it's always, as you can see, an even number. So this is never. It's never odd. It's always even. Okay? For number 10, for a given whole number s, the expression 3s parentheses squared represents an even whole number. So let's try a couple. S equals 1. We're going to get 3 times 1 is 3. 3 squared is 3 times 3, which is 9. For s is 2, we get 3 times 2 is 6. 6 squared is 6 times 6, or 36. And then let's try one more. S is 3. 3 times 3 is 9. 9 squared is 81. So sometimes it's even, right? Because sometimes it's odd. So even, sometimes. Okay. Number 11, a student wants to purchase one pencil case and some binders at the school store. If the pencil case costs $3 and binders cost $2 each, the expression is 3 plus 2x represents the total cost of the student's purchases. Determine whether the total cost of the school supplies will always, sometimes, or never be an even whole number. Okay, so let's try a couple. So if x is 1, 2 times 1 is 2, plus 3 is 5, right? If x is 2, 2 times 2 is 4, plus 3 is 7. If x is 3, 2 times 3 is 6, plus 3 is 9, right? So we always get an odd number. So even, never, right? So it's never an even number. It's always an odd number. So number 11 is never. Okay. Number 12, sports teams. There are 16 players on the tennis team. Let X represent the number of tennis players who are also on the track team. The expression is 16 minus X. It represents the players who are on the tennis team, but not the track team. Determine whether the expression will always, sometimes, or never be an odd whole number. Okay, so let's try it for a couple values. Let's try it for X equals 1. If 16 minus 1 is 15, but if X is 2, we get 16 minus 2, which is 14. And it's always going to be, odd, even, odd, even, odd, even. So odd, we say sometimes, right? Because right here is an odd, but here is not an odd, it's an even. So it's an odd sometimes. And that's number 12. And number 13. There are 24 students in Miguel's science class. Let A represent the number of students who are absent each day. What expression represents the number of students who are in class? So in class are 24 minus the absent students, which is A. So that's the expression, basically. Miguel predicts that the expression represents an even whole number. We have to say if it's always, sometimes, or never true. All right, so if A is 1, 24 minus 1 is 23. If A is 2, 24 minus 2 is 22. So we can see it's always odd, even, and so forth. So even is sometimes. Okay, so that's the solution, and 24 minus a is the expression. And then explain your reasoning. And the reasoning is basically if there's odd, so let's try it 3. So 24 minus 3 is 21. You can see it's always here it's increasing by 1, and here it's decreasing by 1. Okay, so we can just keep going, but it's always going to be this is increasing by 1, this is going to be decreasing by 1, right? Because 24 minus 4 is 20. So when it's odd number of students absent, then we're going to get an odd number of students present. And then if it's even, like 2 or 4, that's even number of absent students, then we're going to get an even number of students that are present in the class. Okay, so these two numbers always have to equal 24. So 20 plus 4 is 24. The number of students present in the class and the number of students absent in the class is always 24, right? Because there are 24 students in the class. So 20 plus 4 is 24, 21 plus 3 is 24, 22 plus 2 is 24, and so forth. So that's the reasoning, the explanation for the reasoning. And that was number 13. And I believe we have 6 more questions from Review for Mastery section. So they are similar in nature. For a given whole number r, the expression 2r plus 3 represents an odd whole number. We have to say if it's always, sometimes, or never true. So if let's try a couple values. If r equals 1, 2 times 1 is 2 plus 3 is 5. And then if r is 2, 2 times 2 is 4 plus 3 is 7. If r is 3, 2 times 3 is 6 plus 3 is 9. So we can see that it's always odd number, right? So it's always. So that was number 1. Number 2, for a given whole number s, the expression 4s represents an even whole number. And we can say, yes, that's true, always. But why? Because if s is 1, 4 times 1 is 4. If s is 2, 4 times 2 is 8. If s is 3, 4 times 3 is 12. So it's always an even number, so always. Okay. And we have a few more problems. For number 3, for a given whole number x, the expression 4x represents an odd whole number. That's right. So if x is 1, 4 times 1 is 4. If x is 2, 4 times 2 is 8. So it's always an even number. Odd, never, right? So it's never an odd number. For number 4, if b is 1, 4 times 1 is 4. 4 squared is 4 times 4, which is 16. And then if b equals 2, 4 times 2 is 8. 8 squared is 8 times 8, or 64. If b is 3, 4 times 3 is 12. 12 squared is 12 times 12, or 144, and so forth. So it's always even, right? Even, 16, 64, 144. So even numbers are divisible by 2, no remainders, right? So in this case, it's always even. So odd is never. It's never an odd whole number. That was number 4. And then we have, I believe, 2 more, 5 and 6. For a given whole number r, the expression 1 plus r represents an even whole number. Let's try a couple. So r equals 1. 1 plus 1 is 2. If r equals 2, we get 1 plus 2 is 3. If r is 3, 1 plus 3 is 4. So we can see they're all, sometimes it's even, sometimes it's odd. So even, we say sometimes. Sometimes. That was number 5. And the last one, let's try a couple. So if x is 1, we get 1/2. If x is 2, we get 2/2, or that's 1. If x equals 3, we get 3/2. Well, that's 1 whole and 1/2. If x is 4, we get 4/2, or that's 2, and so forth. So even, yes, sometimes, but sometimes it's odd. Okay, and sometimes it's a fraction. Even sometimes, and that's it. So please like and subscribe to see more videos, and see you next time. See you guys. Bye-bye.